Guys, sorry the last problem got cut a little short today, so I'm going to run through a quick example, the same one a second time. Okay, so remember when we're looking at the sine function, this is what we did in class today. That's on the screen. The amplitude, period are affected by the A and the B, and the horizontal translations and vertical translations are the C and the D in that model that you're looking at. So come back to this if you get confused, and hopefully that will help. So the example we did in class that I didn't really get to go over is trying to make a model for maximum temperatures in a city. So all the data is given, and we're trying to find the model here, basically looking for the A, B, and the C and the D. Okay, so you don't have to, but the best way would be to probably draw a quick sketch. So I've done that down below here. It's hiding from us, so oops, there it is. If I scroll down just a little bit, right, you can see the months on the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the temperatures on the y-axis. Okay, and it's just a rough sketch. So once I plot those points, I can go ahead and make a curve that matches them. I'm going to do this in green. Okay, so I'm going to start there, and it kind of comes down, and you can see it looks kind of like a sine curve with the up and the down motion. Okay, so you'll find some of the variables easier to find than others. Okay, oftentimes the nice place to start is with the the vertical translation, the letter D. Okay. And so basically I'm looking for what we call the mean line or the median line, and just to get kind of a rough visual estimate, you can kind of see the highest and lowest points, and it looks like, maybe something right about there. Okay, well, that's going to be the average of the maximum and the minimum values. Okay, so to find D, I'm going to look for my maximum value, and I can see that's in, I think, the 7th month, and it's 27 degrees. So I'm going to take 27, and then I'm going to add the lowest one. Okay, it looks like month number 2 right down here is 14 degrees, and I'm going to divide that by 2. Okay, and so I'm finding the average, and it looks like that's about 41 divided by 2, so it looks like D is going to be 20.5. Okay. And maybe that's a little off on my graph there. Maybe I drew the red dotted line a little high, but it makes sense, I hope. So, right, the vertical translation is how high have we moved the median line or the mean line up. And remember, with y equals sine of x, okay, that line is at y equals 0. Okay, so the next piece that people tend to find a little bit easier in this graph to do is probably the A, finding the amplitude. Okay, so I'm going to just scroll down a little bit, and if I want to find the amplitude, okay, right, A is the amplitude. I can either take the highest value and subtract the mean line of 20.5, okay, or I can find the difference from the highest and lowest and divide that in half. And so that's what I'm going to do. So the highest value is 27. Okay, the lowest was 14, and I'm going to divide that in half. So it looks like 13 divided by 2. Okay, this is, right, 6.5. Okay, so we've got piece A. All right, so I'm just going to go to another slide here. I'm kind of running out of room there. Let me close that. Okay. So right now we've got the A value and we've got the D value. Okay. So the B value, okay, has to do with the period. Okay. The normal period was 2 pi, and we know what the period in this example is, right? It's average temperatures. It should repeat every year. So the average period is going to equal 12. Okay. The way I should get 12 is I should take 2 pi and multiply it by 1 over b to get 12. Okay? And if we were to go back a couple slides, okay, and I can show you, right, the period of the general sine function is 2 pi over b, right? I'm looking at that line right there. So our value is 12. So that's what I'm working on right now. Whoops, I meant the wrong slide. Okay, there we go. So a little quick algebra. Multiply both sides by b. I get 2 pi equals 12 times b. Okay, I'm going to divide both sides by 12. Okay, right, divide by 12, divide by 12. And so on the left side, I end up with pi over 6 is equal to b. Okay, and so the last piece we have to do, okay, is to figure out, well, how is this shifted left and right? Okay, I'm working on letter C. Okay, so if you think about this, letter C is, right, the left to right shift or translation. Okay, our normal sine curve goes between 1 and -1, and it starts going up, and it comes back down, and it goes back up like this. Okay, and notice the old mean line was at median line or mean was at 0. Okay, and that's how we did vertical translation. So I really want to know, where is this part of the graph up above? Okay, right? Where do I go across my median line, but increasing? So let me sketch in that median line again, which is, we said, I think 20.5 or something. Okay, there it is. And I'm looking for when I cross the curve and I'm increasing. Okay, right there. Okay, I cross the median line and I'm increasing. So normally we would expect that to be over here at 0. So I can see my graph has shifted to the right, okay, and it looks to be about maybe 5.5 units or something like that, okay? Right? If something shifts 5.5 units, the way I would write that would be f of x minus 5.5, okay? And so there's my value for C. Right? If I come up here, I've got in my model right here, I'm looking for time t minus c. There's my right shift, and that's going to be 5.5. Okay? So putting it all together at the end here, right? So I'm just trying to make a little more space. Here we go. I want y equals a times, So y equals a times the sine of b times t minus c plus d. Okay? And if I remember these values, I think a was 6.5. Okay? I think b was pi over 6. And we said c was roughly 5.5. And the vertical shift up, d was, I forget now. The 13 and a half, I think. Sorry, I'm going to have to look. I've totally forgotten. Oh, D, the shift up, 20.5. Okay. So let's put that into our last piece, 20.5. And there you have it. Okay, I hope that is a little slower explanation and that helps you tonight. There's also a really good example in the book. All right, thanks. See you guys next Monday.